Well, welcome everybody, and may the 4th be with you. I get to say it first. Ha! We're very excited you're here, and really looking forward to the presentation tonight with Kyle Macht. He's going to be presenting about the details of the Twofold Passive House project. The Passive House Accelerator.
Just not that image, by the way. But anyway, go ahead.
What was that? What was that?
Just that's not the Twofold Passive House behind us. That's another project, not a passive house.
That's awesome. So look at all that glass. That's beautiful. So we'll be talking about another project. Sorry about that.
Not a problem.
The Passive House Accelerator is a collaborative online platform for sharing innovation and thought leadership in passive house design and construction. We publish articles and interviews, produce weekly virtual confabs with passive house pioneers from around the world, and we elevate the work and programming of the passive house movement's leaders, practitioners, and organizations through interviews, articles, social media campaigns, video, and podcasts. Our aim is to catalyze zero carbon building by accelerating the adoption of passive house building. With our co-hosts, Kevin Brennan, Shannon Pendleton, Sean St. Amour, and Mark Willey, we produce Construction Tech Tuesday to share the technical, the technique, and the technology of passive house construction tech. Each week, we welcome guest practitioners to dive into the details of practice with the builder and tradesperson as our target audience. We welcome folks from all corners of the construction and design world to join us each week, and we're happy you're here. With that, I'll hand it off to the co-hosts.
All right. Thank you, Stormtroopers, for joining us, and I'm glad you still want to build to the code. That is the way. Vader, you're getting so old that you're using a Mandalorian saying. You're wrong. This community is in disguise as they want to build beyond code. They want to build high-performance buildings, just like Kyle Macht is doing. Luke, you don't even listen to me. You know that I am your father.
All right, Chewy, enough with that blower door test. We got to get this over. I'm Kevin Brennan, also known as Han Solo, here with my foam gun. Just out of doing some passive house work. We're coming from the Millennium Falcon with a PH, and I'm excited for this presentation and this ridiculous skit that we're doing right now, but we're all for good fun, technical, technique, technology on Tuesdays. Shannon.
Thank you, Kevin. I mean, Han. Greetings, everyone, and may the 4th be with you. I'm Shannon Pendleton. Thank you for having just a little bit of fun with us. I'm coming from New Hope, PA, and tonight you're in for a treat because my friend Kyle Macht is here to introduce his latest project, the Teufel Residence, which has just broken ground. So Kyle is a certified passive house consultant with a background in architectural engineering. He spent the last decade in sustainable architecture, focusing on designing, building custom homes, energy consulting, commercial buildings and homes, home performance contracting, and renewable energy systems. Today, he applies his knowledge to building science and low carbon architecture as principal of Macht Architecture. In his spare time, he enjoys spending quality time with his family, and we got a wonderful preview of that last night. He likes to explore the outdoors and engage with the Instagram community, watch movies, and support his favorite sports teams. So put your seats in the upright position and put your questions in the chat, and stick around for the after hour, because Kyle's got an interesting personal road to passive house that's just as much passion as path. And with that, I will hand it over and welcome Kyle Macht.
Thank you all, everybody. I guess I'm going to have to be Ray or something, but I don't have a costume. But I will take that role. So let me share my screen here.
And also say that he'll be at Building Energy Boston on Friday. So I'll put that link in the chat too, and hopefully you can connect with him there as well.
Sounds good. And you'll be there with me as well. As well as a few others, including Steve, who's in the audience, and Ilka, who said she was going to be in the audience. Anyway, so this is the Teufel residence. This project started, I guess, about a year and a half ago or so. And the client who originally came to us was from California and wanted a sexy, modern California, Southern California, not typically done on the East Coast or somewhere where you actually need to heat a building, in Pennsylvania. And so reached out to us because of that image you saw earlier, which was a past project that was not a passive house, but we still implemented passive solar strategies, even though it was a ridiculous amount of glass. But anyway, so the Twofold project, the main driving focus here was modern, innovative, sexy design. And so that's what the client came to us for. And we slowly started the sell on sustainability, energy efficiency, comfort, durability, and really thinking bigger than just the simple strategy of sexy and modern. And so our goal was to take that sexy modern strategy and turn it into something that was passive house or something close to it when we first started the project. And so jumping ahead a little bit here, we did end up getting pre-certified for this project. And you can see our criteria on the right over there. So we were able to get pretty low in some of those categories to be able to meet that pre-certification process, even with the size house this was at 8,000 square feet. We had quite a large team on this project. This was the largest team I've ever worked with on even a commercial project, which wasn't too many. But so it was myself and my dad, Paul Macht, the other principal of Macht Architecture, that was leading this group of individuals to try to realize this project. We have the builders to the right of us from Hanson Fine Home Building, or Hanson Fine Building, and Chris Hurl, the third one over. He's the site project manager. He's been doing a fantastic job so far. It's really, we've been all pushing each other on this project to really make this something better. The client, Teufel, on the right, and then Steve and Ilka on the bottom left-hand corner there. They've been instrumental in this project, and I'll talk a little bit more about them later. Then we have a lot of different consultants, from structural engineers and designers, interior designers, landscape designers, lighting designers, and then mechanical, plumbing engineers, and energy modeling, and all of those different things from many different parties. And so this project is located just west of Philadelphia, sort of northwest in Gladwin, which is somewhat of a wealthy community. And the client found a piece of land there that had an old large home on it. And that home was kind of nice, but nice from 1970s, kind of nice. So we were first brought in to look at that existing property and look at that existing home and sort of evaluate it on, is there anything worth saving? Is there anything worth considering differently here than just tearing this down and starting over? The client fell in love with the site pretty quickly. Fortunately, all these pictures are from fall, so when it's all green and beautiful, it looks a little bit nicer than this. But anyway, so we were first brought in sort of as a pre-existing conditions, and then I got to throw on that energy consulting hat that I started with Norm, who's in the audience with. And so I was able to go in, sort of dissect this house, and pretty quickly come to the conclusion, all right, there's a lot of water issues, that musty smell as soon as you walk in that door. It's going to take a lot of work to try to revamp this to make it the modern palace that the client wanted. Maybe take it down to the foundation, but the more we analyzed it, the more we thought it wasn't worth it. And what we decided to do instead was deconstruct the home. So we had multiple different parties come in, take out what was salvageable, sort of strip and gut the whole inside, and then deconstruct it appropriately and recycle what we could. And that ended up being a big tax write-off for the client. So even though it took a little longer than do that, it was worth it. And then we were brought on in full architecture mode for the preliminary design. And so in this process, a lot of time to explore. And so this client was great because he gave us that flexibility to really try different things, try different designs, got out some foam blocks and really played with a lot of different ideas. And then from there, we went to schematic design. And this is where we started really thinking about how are we going to execute this? How are we going to get to somewhat passive house-ish, I keep saying, and get closer to that. And so at this stage, we're doing some floor plans by hand, some simple 3D exterior modeling, a little bit of the interior, but really just, hey, how do we keep it simple and easy and quick so that the clients can visualize multiple different versions? And at this point, we also got quite into detailing. And not all these details I would recommend, all but detail number 7, that wall to roof detail. We were really trying to think about how do we do this completely foam free. That detail doesn't work. You need a lot more slope to get that to ventilate properly on top of a flat roof. That was another thing. The client wanted a flat roof. And so, how do we achieve all of these different things and get there? So our old wall design when we first started this project was, all right, let's just do it as sort of that Joe Stiebrick perfect wall, simple execution with 2x6 framed wall filled with cellulose, and then some type of good membrane. We were going with Solitex Mento at the time on that. And then we had 2 layers of rock wool on the outside with a double lattice structure and vertical siding. So that was what we sort of started with, thinking that was a decent wall assembly, maybe not as good as it could be, but definitely moving in the right direction. And looking at the foundation, we were sort of just planning on doing insulation on the inside, but we were paying attention to all the different details. Main reason we got into this level in schematic design is because we were going to be interviewing about 5 different, maybe 6 different builders at this point. And we wanted to make sure that if we threw this at them, they understood the essence of what this project was supposed to be. And so there was a lot of different builders that we weren't sure whether they could handle the high performance side of this project. And we were trying to also show that to the client through these interviews of, hey, look, they don't understand these details at all, or this seems foreign to them, or they like this, or they've never done it, or whatever it may be. But that's why we end up doing detailing early on in the project is really client communication and more builder communication and trying to get the right builder on the project. And if another builder wasn't hired, at least they're exposed to something different and more progressive. At this point, we also brought in Positive Energy, who was the mechanical and plumbing engineers on this project. And they did a whole bunch of different studies for the project, looking at how the trees impact the windows and shading analysis, insulation, looking at glare studies and all different types of lighting studies. And so they were really helpful to try to fine tune some of the project to make things work and perform a little bit better. Luckily, from our past experience, we were getting pretty close to that optimal performance, and we could have tweaked a lot more things, but to get the design the way we wanted to, we were pretty close. But they were really helpful. And so getting into design development, this is where we really wanted to, we've got this amazing project, and the more people we're bringing in, at this point we had Hansen on as the main builder, and we really wanted to make this project something better, something more unique, something more progressive. And so talking to the client about embodied carbon, the client was all for it, but wasn't really interested in paying that much for it. And so how did we manage that? How did we go to try to reduce the embodied carbon as much as possible without increasing the cost too much or none? And so that was one of the big things we started talking about. And we went to the Passive House conference in DC I guess that was a year and a half ago or a year ago or so. And in that same room with us was Steve and Ilka, and they did a presentation on embodied carbon. And we were interested in potentially working with them and bringing a panel manufacturer in, which I'll get on in a second. And so that presentation was sort of like, yes, we really need to think a little bit more progressive about this. And so the conversation came up from a builder and from us and the client. Everybody sort of seemed intrigued by, what if we panelized this? What if it was all built in the factory and brought on site? And so one of the main things that really got me excited about that was carbon reduction. And so we looked at, what if we panelized it? What if we built it on site? And we had a lot of trouble getting FSC lumber from different local sources, even shipping it in. It was either really expensive or difficult to source. Going panelized, super easy. Most of the people that we were talking to about the project could do that, and it was part of their process. Wood fiberboard, also part of the process. That was something we wanted to start doing instead of the mineral wool, to reduce carbon emissions and still allow that vapor drive or vapor drying to the exterior. And so we really started getting interested in this. The client was really excited about it for speed of construction and also greater level of control over the precision of the project. And so this is some of the photos of the walls being produced. This is happening right now. And so we ended up going with Holzstrom's system. And so they have a 2x8 framed wall cavity. With this project, we ended up using hemp bat insulation. And then on the outside, a 60 millimeter Styco, the wood fiber board. and then a double layer 1x3 lattice structure. But in between those, we have Solitex Mento Plus for extra durability. And so that is being fastened on with the lattice structure. And then we have a vertical Akoya wood Shishugi bond siding for extreme durability. That should be a 50-year product. So we are thinking sort of long-term in terms of our material selection there. And the client was also thinking very much about the aesthetics at the same time. So how did those marry together? On the inside of this, we had our zip sheathing, and that is our main air control layer. The Solitex Mento Plus is our secondary air control layer. And so that allows, the zip is really our vapor control layer as well, acting as a vapor retarder on the inside, slowing that moisture drive through into the wall assembly. And then if there is any moisture that gets in there, it can all dry to the exterior. Inside that, we have a 2x3 service cavity running horizontally with 5/8 gypsum on that. So the other big thing, what do we do with the foundation? Concrete. It's so carbon intensive. And so we really started looking at what are all the different options? Do we panelize? Do we do something crazy? And that something crazy usually was not working out. And so we were looking at a lot of different ways. What if we remove the slab in the foundation? And we were looking at all these options, and we landed on Ideal Building Systems as our precast foundation wall panel. And so from this selection alone, we were able to reduce the concrete usage by about 50% compared to the other strategy that we started with, which was just a poured concrete foundation wall. We did look into carbon cure and multiple other variations of different technologies like that. They were either the concrete supplier wasn't able to get it or wasn't interested in doing it, and not for the panels either. Now, these panels do have a higher cement content inside the concrete, so it isn't quite a 50% reduction in carbon emissions. We're going to be involved in a carbon study with the new calculator from Chris Magwood and Endeavor Center, and also New Frameworks, who's been a part of that process. And so that hasn't started yet, but we plan on doing that soon. We're hoping for about a 40% reduction here. I was talking about trying to remove the concrete from the slab. If we remove the concrete, we'd have 2 layers of Advantech, 1 layer of sheet or deep in that. On top of that, we've got mortar, tile, and so that's a lot of different layers built up there. We haven't done that calculation yet, but we plan on getting to it. So we ended up going with the concrete. The client was interested more in that as the final finish anyway. So one material instead of a buildup of multiple materials might be slightly higher in carbon emissions, but I didn't feel too bad about that. The last one, that same conference, at that Passive House conference, the next presentation was about refrigerant usage and how super carbon intense it can be. And so we started thinking about that. And in that same room with us was our mechanical engineers and positive energy. So they were also there. So the panel company, mechanical engineers, the architects, all in that same presentation, watching that together. As soon as it was over, like, this is the project. We need to do something better here. What are our options? And the other thing, the sightly eyesore of this, that's why I chose this photo, because it looks ridiculous. And so we were trying to figure out, with a 6-zone mechanical system, how do we do this so we don't have condensers all over the place? Or maybe we needed to create a mechanical pen. And so all of this started leading us to ground source heat pumps, the thing I normally have been steering clients away from for the past 10 years or so. I think the last one I did before this project was with Norm from Infinity on another project. And so actually that one wasn't that one. Anyway, we did some at Infinity with ground source heat pumps. And so we decided to use that for multiple reasons. One, the big one, all the refrigerant got condensed inside this box, factory installed. So instead of a 10% leakage assumed per year, which would outweigh our carbon emissions from the embodied and the operational by a lot. I'm looking forward to finalizing those numbers and that embodied carbon calculation and the whole life cycle calculation. But the refrigerant usage ended up being the biggest sort of carbon emitter for our project. We're net zero, whole big solar array on the roof. So our operational carbon emissions are somewhat reduced from that. And then the embodied carbon emissions we're already reducing from the core and shell package and some of the material selections that we're making. So next was refrigerant. The other big sell, this was an increase in cost. We went from about a $170,000 mechanical system up to about a $230,000 mechanical system. It wasn't quite all just because of the VRF to ground source heat pump switch. There were other things in that too, but maybe 30,000 of that was from the heat pump switch, which was like 5 to 10%. But long-term thought process there. Upgradability, way easier to deal with a water distribution system than a refrigerant distribution system. And so we can replace one air handler very easily without having to worry about refrigerant leakage, and without trying to worry about, is the technology too old from the VRF system? Does the whole system need to be replaced in 10 years? This we can replace parts at a time, and it's a lot more plug and play, and should be longer lasting. So that was a big driver in this process. And I'm really looking forward to trying to make this a little bit more typical. And I'm really hoping for air to water heat pumps as a new thing here, which you can see with our domestic hot water system. We use the sand den system. So we sort of have one air to water heat pump, and then we have multiple ground source heat pumps, water to water in that case. The ventilation system, we have 2 Comfo Air Q350s, and then we also have ultra air dehumidification systems tied to different air handlers throughout the project. And so some interesting things going on here, but we were able to really make some efficiency gains. The other cool things that we're doing, we're using the ground source loop and the heating from that to preheat the incoming makeup air for the kitchen exhaust, and then also to preheat the sand den unit instead of using that electric resistance. And Miguel, if you're listening, I don't know if you are, make sure that happens for me. Anyway, so the other giant fish to fry here was, what are we doing with these windows? These windows are gigantic. We want them to be huge. Aesthetically, the feel, everything, that was the client was really after. And so how do we do that? And how do we make them sexy, beautiful, humongous, yet still getting towards passive house? And at this point, we had the panel company on board, we had the builder on board, we had ourselves on board, Positive Energy, and Ilka from Holstrom was starting to do preliminary calculations for us, for WUFI modeling, to try to sell the client on, hey, can we go passive house? And we found that we're really close. We didn't really have to do too much. We were already there. And so it was more about going through that process. And the client was like, you know what, let's do it. No, I'm on board. And so in the window selection, we looked at many different manufacturers. We probably had about 20 to 30 different lines of windows that we looked at. And EnterSign was the end up major selection that we made. We were super impressed with their clean sight lines, and same passive house conference when I first saw this product. But you can see in that bottom left image there, that sight line from inside to out is straight through. So you can get a really clean, super modern look. We were looking at maybe over insulating the entirety of the exterior, but we only chose some of it. The other cool thing with this, most of the windows were 8 feet by 10 feet. In that bottom right-hand corner, that dark image, that center piece of glass, there's going to be a gigantic painting behind it. So the client was really interested in really showing that off and didn't want that vertical mullion running through that. That would have been about 8 inches wide. And so we were able to do a 14-foot wide by 10-foot tall piece of glass that was special, custom order, a little bit more expensive there, but the whole glass package came in at about $90 a square foot, which was definitely on the high end, but that was comparing a lot of UPVC and different other, some fiberglass, but most of the wood aluminum clad were in a similar ballpark in terms of price. So we were really happy with this product. I'm really looking forward to installing this. So getting into some of the details, that's what I was really hoping to dive into here. And so one nice thing with the Ideal Building Systems wall, we're burying that foundation below. This is actually their standard detail. So there is a complete thermal break at the bottom of that foundation wall. EPS foam type 9 running up into the foundation panel, and then 3 inches of continuous EPS type 9 at the bottom half, and then type 1 at the top half, the 1 pound density. And we were able to change their typical detail for the top of that wall and cut that back so that that 3 inches of insulation was continuous all the way up to cover the top panel that you can see in that right image there. And so that way we've got a pretty good thermal break running around this entire foundation system. And that one's usually the tricky one to do, especially at the top of the wall there. And usually we're just say that's a concrete wall, and you just run that insulation on the inside. So at this wall, the other nice thing, we were sort of looking at Superior Wall or IBS. And so with Superior Wall and some of IBS's walls, there's extra steel studs in the wall, and there's XPS foam. And once again, we're trying to remove carbon emissions, and EPS foam is cheaper. So in this scenario, we used all EPS foam throughout the entirety of that panel. And then we're, for fire purposes and service purposes, and to get a little bit of extra insulation, we're putting all the service cavity insulation on the inside there too, in that 2x4 wall cavity. And we're pulling that off the foundation wall just a ½ inch or so to get a little bit of cellulose back there. And so we're really interested and excited about this detail. Shannon actually had a project right before this working with Holzrum. And so they ran into an issue with how to seal their vapor control layer underneath the slab to ICFs. And in this scenario, we have EPS, so still a tricky detail. They originally taped it, found that the tape wasn't really sticking well to all the different ridges, so they did a fluid applied membrane. We sort of were thinking about that of what do we do? Do we just fluid apply it on top and rely on the EPS? We all sort of felt, let's just put the extra money a little bit into the membrane and just bypass the entire foundation wall panel. So we'll be putting either Intello or Solitex Mento, tying that into our Pango wrap, which is termite resistant underneath our slab, and tying that up over the top of the foundation wall and wrapping that back over the foundation, which you can see in that red line on that right image, and then taping that to the interior zip sheathing on the first floor wall framing. So we're just sort of bypassing the entire foundation system and that sill plate condition at the top of that foundation wall. I see so many details on let's seal, sill gasket to 2x and all of these different things. So many different transitions. Yes, it can work, but it's a lot of goopy stuff everywhere. And I prefer just to wrap a membrane through there. We do need to seal it with a little goop where all those anchor bolts are penetrating, but at least it's just one little ring. So we're really excited about this detail. We'll be executing it soon. And I'm excited to see how that one turns out. The other scenario that we had was on the other side of this foundation. It's mostly a walkout basement on this side. Other side, we have grade going up close to the first floor and up to first floor in some circumstances. So in that top right image, we realize once you get rid of that floor insulation there, you really got concrete, double sill plate, subfloor, and then bottom plate of the wall above. Sort of a big chunk of wood as a huge thermal break there. And so what we decided to do was put 1.5 inches of type 9 EPS underneath that sill plate there, just a continuous layer around the entire top of the foundation wall. I'm talking with the builder, he was like, just let's do the whole thing. It's gonna be way easier to communicate. And so that's what we decided to do. Underneath where all the point loads are coming down, we worked with our structural engineer to figure out which version of Armatherm made the most sense. So we have a little bit of extra coordination here, but completely thermally broken around this transition, which might be a difficult one. Roof system. This was another one that we really struggled with on this and multiple projects. We have 2 flat roof projects at the same time. And 475, I've seen a lot of their presentations on how to achieve this. Passive House has other ones. And so our goal was to not use any foam inside the control layers, inside that, well, I guess our air control layers on the underside of this roof cavity, but the whole cavity insulation is all cellulose. And that was what we were trying to achieve. On top of it was a sloped tapered polyiso. We did look at what if we didn't do that and tapered the trusses or tapered the eye joists, which they ended up being, and look at different strategies there. But after doing some modeling that Ilka was instrumental in helping us out with this and doing different woofy scenarios, these woofy models were actually done by theists themselves. And this is another little tricky part that we got into of what membrane to use on the underside of those eye joists there. And so started out with Solitec or Intello, and that seemed to be what it's designed for. That makes sense. We have tested data from that from past projects, not ours, but other ones. And then we've also seen a lot of woofy modeling done. However, Passive House Fias changed their modeling methodology, and now they do it just slightly differently, which changes the product selection. And so from their new modeling methodology, they had concerns about the variability of that vapor control layer of that Intello, and they thought it was too vapor closed to allow enough moisture to dry down, because we're relying all on downward drying potential. Some of our roofs, we can rely on solar drive, some we can't. We have PV system up there, as well as some roof terraces. So we're really relying mostly on solar or drying to the inside. And so they wanted us to use more vapor open material. We're still trying to figure out exactly what that's going to be there. I'm still thinking Intello makes more sense, but in order to do that, we need to do some other things. So real quick here, we were also looking at how do we extend those overhangs? How do we deal with overhangs? And I'll get more into that in a second. Window installation, that ended up being a big one back and forth with us and Holzrum and the builder. All of these windows are going to end up being installed on site. Definitely a little bit of a downside, but we were really excited about the possibility of installing them in the factory. But we have floor, this is the typical detail. These are the all non-typical details. Most of our windows actually go floor to ceiling or wall to wall, and they're actually not in a panel at all. They're their own wall panel. And so those we're going to be installing on site. So we talked about all the different coordination, who's going to be doing what, who's prepping what, and so how that's going to be achieved. The other scenario, what do you do at the bottom of the window? So what we've decided is we are going to tape that, and we're going to rely on drying only through Tescon Vanna tape at the bottom of that window. That seems to be more the European methodology. Building Science Corporation might poo-poo that, but we're really using a high quality installation, really high quality window here. If there is any moisture that gets down there, it will be able to dry. If there's a leak, that will not be able to drain as easily, but I'm not too worried about that. Another reason why, we have 4-foot overhangs at meeting this window in most scenarios. You can see that in the bottom right there. Most of the time, our windows are going up to a soffit. And so there's really minimal chance for a lot of water penetration in these windows. Where we are having a window without an overhang on it, the plan is to maybe put in a vapor diffusion port or a little drainage port, sort of like a weep hole that we're taping around to allow that excess potential water 50 years from now to drain out. And so working with Holzrum, they went through their entire process of how are we treating all these details? How are all these different systems connecting? Where are all those control layers connecting? And so Ilka was instrumental in that, and so was Steve at Holzrum. And so we worked together pretty thoroughly on all of these details and figuring out all of these different conditions. This was another one that sort of came up, is how do we do all these big overhangs? How do we deal with those penetrations in our control layers? And so we were worried about thermal control layer, air control layer, vapor control layer, and the water control layer there. And so water control layer we're bypassing, and that's wrapping around the parapet, and around the overhang there. But our primary air control layer was on the inside, on the underside of our roof system. So that was bypassing any type of point load through it. However, our secondary air control layer was the roof sheathing, and that can carry down to the outside of the Solitex Mento. So how do we seal between where 2 layers of LVLs are coming together? Do you core and fill? Do you squeeze some Contiga between those, some type of acoustical sealant? And so that's what our plan is to try to seal right at that penetration. Secondary air control layer, but still a concern, still something to keep in mind. Other option was to tape around the entirety of that LVL protrusion there and sort of include the whole thing. But our goal is to just try to fill between there. We'll see how that works out in the blower door test. Also, a little bit of steel in the project. We've really tried to limit the usage of steel. We have basically just 2 steel beams left and 1 steel column. Everything else we were able to get down to wood. When we first started in schematic design, there were like 10 steel beams in the project. Then this is my last big slide, mechanical and structural integration, the SIM model. And so this is where we spent a lot of time with all the different parties. This is Steve Hessler's baby. And so he helped us a lot in terms of figuring out how everything got coordinated and how all these different pieces fit together. Also, super modern home. We didn't want soffits all over the place. We were trying to keep it super clean, super minimal. So we had 24-inch floor trusses on the first floor, actually 30 inches on the second floor, but that was more to get the height difference to get down to a terrace. And so anyway, this was a big part of coordination. With that, that's my last line.
Absolutely fantastic. Thank you, Kyle. I love that you've landed on this image at the end, and you've covered so much with this project that, again, it's like drinking from a fire hose. This is becoming my mantra now. It's
I get told that a lot.
All at once, and I appreciate how much you put into this presentation to share it with everybody.
Force is strong with this one.
Looks like the force is strong with this one.
Great stuff, Kyle.
Nice job. Excellent. I can't wait to find out what the blower door test is going to be.
Me too. Me too. There's going to be 3 of them. So
you're getting a lot of accolades in the chat. We had a lot of questions come in.
Okay.
Where are you in the process with the pre-certification? You're complete. That's completed, right?
The pre-certification is complete.
How many thermal bridges did they make you look at?
I think there was 3 conditions that they wanted us to consider, and some of those were because the drawings weren't up to date from what they saw last. So there was really only one condition, I think, that ended up being the primary one, and that was that thermal point load that I was talking about here.
Yeah.
So that was, I think that was the main thermal load. And then this one, where is it? This one that I was talking about was the other one, but this one we were already in the process of solving as they were getting back to us. So we knew this one was an issue. We knew this one was an issue, and this one was the one we were just going to say, it is what it is. We'll throw a little bit of extra insulation potentially underneath that double LVL there. Some places it's not quite a double LVL and it's a little bit more, so definitely a concern. But we're gonna make sure we mitigate that as much as we can.
I wondered because it looked like from your thought process you were identifying these and approaching them before you probably were asked to look at them.
That's absolutely correct.
Yeah.
This exact condition I was thinking about in schematic design of how we're dealing with these thermal point loads, especially the overhang. And in all honesty, we had another project similar to this that we designed right before this, not passive house, but going close to it. And so we were dealing with some of those conditions here. So we were sort of primed for this in this project of how are we going to deal with these big overhangs and how are we going to do it in the best way we can to not increase cost, make it not too complicated, but also make sure it's not missed. Sequencing is super huge in this type of condition here, and making sure that's not skipped, because if it is skipped, now we've got to rely on taping on the outside. So sequencing super critical.
Kyle, can you go to the photo of the EPS preformed foundation? So I like this one because this shows the air exchanges of a code build house.
Mm-hmm. It does. Yeah, this one we couldn't get the blower door up high enough.
That's exactly it. But so for the audience, this is actually where the project sits today, right? This is how far along you are in the physical world of the project, even though the rest of the project has been built 2 to 3 times virtually. And it's a very impressive site, and I enjoyed the presentation immensely.
Thank you. Yeah, those panels are being manufactured now. They're halfway to 2/3. Steve can update us if we need. But we're hoping that in a month from now, there's a big core and shell on top of this foundation. So it'll go up pretty quick, but it'll take a little bit of time to do all the different layers. But the floor pieces are all panelized, so those will come down pretty quickly. And that was one of the main reasons for that, was to speed up construction. If you're interested in learning more about that, on Friday at the NESI conference, if you're going, we have another presentation that will be getting a lot more into the SIM model and the coordination behind that, and sort of the challenges that we got through from permit submission. That was a nightmare, and all sorts of different challenges that we encountered in the panelization process of this project, and the benefits too.
Thanks, Kyle. Well, it looks like we are positioned in a nice spot to take some questions. If you're ready to field a few questions, Kyle, how does that sound?
Let's do it.
Excellent. The first one is from Cornerstone Architecture. And I didn't check to see if they were on right now, but if they are, please unmute your mic. Looks like they are no longer on. So I will ask Cornerstone's question for them. And they were curious about the name Twofold. And you know what? I actually noticed that Ilka answered this question in the chat, the client's name. But Kyle, you mentioned it's pronounced differently and it does have a meaning. Is that right?
I don't remember what the meaning is actually. Ilka would know, but Teufel is actually, I guess, the real pronunciation. But they changed it at some point a long time ago, and so Teufel is the way it's pronounced.
Our Americanized version.
It means devil.
Does it really?
Yeah,
Yes.
I actually asked the question. Sorry, I logged in with the wrong account.
Ah, thank you, Sandra. Welcome. Welcome.
Wow.
Yeah.
This client
Yeah.
was certainly not a devil.
But it was
one of the best
already
clients I've worked with.
answered. So the combination of devil and power, like Teufel and Macht,
Yeah,
pretty cool.
Devil
and
power.
lowercase
Devil's
fox
in the
to do or
details.
to make.
Yeah.
Thank you. All right, well, our next question is from Han Solo to everyone, who actually more of a statement on the same lines that you don't need to disguise, Kyle, because your last name means force in German. So Trevor Fedya, am I pronouncing your name right, Trevor? Would you like to unmute and ask your question, or I can ask it for you?
I was just curious if the original house had a conversation pit in it, because I have a weird affinity for those.
I don't know. It was not that desirable, this place. So we were happy to get rid of it.
Thanks.
We did have to go a little bit deeper. The one big question was, this was sort of like a split level as you entered. And so that was a big decision of, where do we put all these elevations? And so we worked heavily with the landscape architects and trying to figure out how we want to do that, because the client was more interested in walking right in. So we did actually dig a little bit deeper and use that digging, I believe, to fill in the pools that used to be. So.
Cool. Thank you.
Yeah.
Thanks, Trevor.
Trevor, you win the award for the most technical question of the evening, by the way.
So Harvey's up next, but Harvey, I think you had 3 questions. Maybe kick us off with 1.5.
Well, I'm just going to follow Trevor and just ask, was there shag carpeting on the walls? That would be the first one. I mean, that conversation, that was probably, I don't think that was the night. I think that, Mark, that was the best question ever. I think Dr. Feiss is rolling right now in bed over that question. What was sorry, I got to ask the Harvey question. What is the budget for this bad boy in total?
That's a great question. And so,
of course it is.
Budget
That's why
here was like $2.5 million. And it started at 5,000 square feet of house and 1,500 square feet of art barn was the original ask. And so we ended up saying, hey, you've got this giant basement. Maybe we should be putting the art barn in the basement. And so that's sort of how that formed. And then we were talking about, by doing that, maybe we could create some interesting interconnectivity from the house to the art collection and let it start bleeding out. So the whole basement, a big portion of it is a huge art gallery. So it's not 8,000 square feet of all above grade. That's including the entire basement, including unfinished space.
Incredible.
But and so, okay, so I started out 2.5 million at this stage. It crept up to 5.5 million. And so we got over 6 at one point. We made some design decisions, really just some smarter detailing to simplify a couple things, and got it. We're down to 5.5, maybe 5 by the time we're done.
So about $1,000 a square foot to build of like above grade? Is that what you'd say?
It was about $800. Well, the total square footage was about $800 a square foot. A lot of that, so the core and shell was a way smaller portion of that. So mechanical systems, I said, was about 240,000. All the MEP was like maybe $1 million together. And so core and shell, site work, all of that was sort of like $1 million. And then, well, actually core and shell and windows was like $1 million. And then the rest was all finishes. Finishes was what drove the cost in this project. And that was, you know, completely the client's decision there. And I think he really kept things clean and simple on the inside, but definitely went for some nicer things. So.
Hey, Kyle, I got to jump in here. So technically, this would be the first certified art gallery, Passive House art gallery in North America, correct? Right? I think that's how.
I guess, sure, why not?
Yeah, yeah. I think that's
it's art gallery. He does plan on having actual exhibits here, so.
So then what kind of finishing, because I don't think you showed a lot on the inside. What is the finish? It's not just basic drywall. Like what's the other finishing to jump it up
is
to
basic
such a high?
drywall.
It's just basic
for the most
drywall
part.
skimmed. Wow.
Yeah, level 5 finish. But the cabinetry is expensive. The lighting was expensive. We didn't want to go too crazy with the lighting. We did simplify that a lot. COVID is expensive. That has brought up the price a bit. Windows was about like 200 in the mid 200,000s. So it was a lot of railings and the exterior, the core, the mild steel, the rusted mild steel was, you know, kind of pricey. The Akoya wood, Shishukiban was about $18 a square foot. So, you know, it all adds up. The site work was a lot. So demoing the existing home, dealing with all of that, we had to go through an insane permitting process because we were disturbing over an acre. So there was a lot of involvement in that. So the site work itself was a huge cost of the project, like 500, 600,000. I forget exactly what it ended up being. But it was, you know, it all added up a lot. And there was about $1 million that wasn't the house, was all of the other stuff besides just the house.
Can I just ask one other question? Sorry, Shannon.
Yeah.
Is this how long, Kyle, have you guys been on this one, like from conception to where you are now?
I want to say it's a year and a half. I'm trying to remember. Where's my other notebook? I think it's about a year and a half.
Okay, that's great. Thanks so much. Appreciate it. Great presentation.
Thank you.
So, Kyle, at this point in the show, we run into the world of acknowledgments, and there's someone in your life that has allowed you to be who you are today. Would you care to take over?
Sure. So in that mentor question, we talked about that last night, and they encouraged me to actually tell my life story because that sort of tied into recognizing the people that I've been with over the years. And so the guy on the left, my dad, who I believe is listening. Hi, Dad. And so Paul Macht, he started the firm back in 1990. His master's thesis was on passive solar design. Most of the people that he was presenting to thought it was all symbolic or conceptual, and that it wasn't to do with energy efficiency or anything besides that. It was all architecturally symbolic. And so, no, he was one of the pioneers in this. So I'm sort of second generation energy nerd, I guess. And so I started wanting to be Tony Stark, or, you know, sort of design weapons and cars and be a mechanical engineer. I wanted to do that since I was 5 years old. Started at Penn State as a mechanical engineer. And then after freshman year, I started really falling in love with modern architecture. I saw all of this incredible architecture over the years with my dad, him taking my brother and I and my mom to all these different places. I couldn't care at all. I was, you know, dealing with all the other stuff and exploring other things and seeing all this amazing, beautiful work. And it wasn't until later in life that I started respecting it and loving it. And so I had some friends in college that were in architectural engineering, and I really liked their homework assignments better than my own. And so it was really the involvement in that made me switch to architectural engineering. At this point, I became an intern at Paul Macht Architects, the old name of the firm. And so this is the house that I grew up at. It was a passive solar deep energy retrofit to another project. So we tripled the size of the house and decreased the utility bills. And so, you know, this was, God, 25 or more years ago, 26 years ago, that this was done. And so learned a lot from just growing up around this stuff. The other big influencer, so I learned a lot from my dad. I learned a lot from Penn State Architectural Engineering, got a bachelor's and master's there at Penn State, but solar decathlon, I went heavy into that in 2007. And you see that girl in that bottom left-hand corner, that is now my current wife. And she really has pushed me out of my shell. And so I can't thank her enough for allowing me to become the person I was. I was very shy. And so she really pushed me out and pushed me towards solar decathlon and pushed me towards architectural engineering and helped me become the person I wanted to be. And so 2007, I was sort of the jack of all trades, did so many different things in that project. That was an incredible project. A lot of great people, friends for life. And then 2009, I was pushed in to be the team leader. So we had about 200 students below me, really a core team of 16 students there. And so that was a lot of fun. My wife was involved in both solar decathlete projects. And so this project, we actually built a secondary home on the Northern Cheyenne Indian Reservation of straw bale construction. So we built a technical core, straw bale, other side, and sort of built the two together, and I helped manage that project. So back in college, I was doing all of these crazy innovative projects. I didn't know what standard construction was back then. But as soon as I left college, well, actually the end of college when I was doing my master's, my dad and I decided to do a project. My parents bought a piece of land. We designed and built this and still own it today. So this was sort of our representation back in 2009 of what the ideal home could be. So all passive solar, huge embodied carbon in this one, polyurethane, Mura-SIP construction on the walls, EPS SIPs on the roof, which isn't quite as bad. But net zero, 4 kilowatt solar array facing the wrong direction on the roof. But that's a whole other story I won't get into. Next, I moved on to a company called Invinity that Norm is listening right now. He's from Invinity. I was their 13th employee. Norm was like their 40th. I don't know. It was a lot after me. We grew insanely after I joined. But these are two projects I designed and built. Norm helped build the one on the top there. At Invinity, I also did commercial energy consulting. That's where I started. Then went into residential energy consulting. Solar, I did a couple of solar installations. They did timber framing. I got to do a little bit of that. Home performance contracting. I was willing to put on a tool belt and help out. So I did a lot of dense pack cellulose and loose fill and attics and all sorts of different things, but eventually got over to the design side and helped manage that team and design and built these two projects. So that other expensive project, this bottom project built in a less expensive place to build, we built that for about $150 a square foot. And still not net zero, but somewhat high performance, not quite as high performance as some of the other projects I've been on, but definitely cool. And then I went back to school for architecture. And so Invinity also got involved in this project, but I got involved with another student competition called the Race to Zero competition. And so this was the project that we designed for that. And Invinity ended up building it as a low-income housing at State College area. At that point, my wife got a job as a professor at University of Rhode Island. We moved out to Rhode Island and called up my dad and was like, hey, I don't have a job right now. Maybe we should get back together. We've talked about working together and partnering for a long time. And so that's where we joined forces in 2015 and did some pretty innovative projects together. I have to say Twofold has been the most innovative, progressive project we've been involved with, but that one on the left there has been pretty progressive too. That one is going to be on a Nessie home tour in the upcoming future. And then in the bottom right-hand corner, that one might be a passive house as well. Depends, that's my dad's project. You've got to just have to convince him that we need to go through the certification process. And that even though Teufel has been a long certification process, maybe it doesn't always have to be a long certification process. But anyway, that is my life story in a nutshell.
I liked having the images to go with that this time. That was very rich. It was so, you left a lot out too, because you had some other good tidbits, but we'll save those for the after hour. I know that we're all now wanting to dig into these projects as well, but we have to hand it over to Zach, who is going to close out our first half and open up our second half.
Yeah, thank you, Shannon. Thanks a lot. And Kyle, fantastic. So I announced last week that with Rockwell's support, our founding sponsorship circle is complete at Passive House Accelerator. And we deeply appreciate the founders helping us launch the platform and now sustaining it with continuing major support. With the closing of the founder circle, we've opened a new category for major sustaining support called champion sponsorship. And we're happy to announce that Siga is our first champion. And everything we do at Passive House Accelerator is thanks to support from our sponsors. That's how we do all of this programming. So thank you to our founding sponsors, 475 High Performance Building Supply, Backstingui Architects, Mitsubishi Electric Train HVAC US, Partel, Glavel Foam Glass Gravel, Minotaur All-in-One HVAC and Dehumidification, RDH Building Science, Rockwool, Stocorp, and Zola Windows. And thank you to our champion sponsor, SIGA. Big shout out to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. And thank you to our patron sponsors, AeroBarrier, BR+A Consulting Engineers, Brennan Insulation and Airtightness, Innotech Windows and Doors, and US Engineered Wood T-Stud.